Hey, I'm Brett Slatkin, a software engineer here at Google. We're here today talking with Brad Fitzpatrick, who primarily works on the Go programming language. And today we're talking about Camlistore, an open source project that he leads. So, Brad, what is Camlistore?
We've been calling it a personal storage system for life. It's basically a place where you can put all your data and not really worry about it. Just throw it all in there like kind of a little data dump truck and trust that it'll be there for many years. You can move it across different providers, or you can run it yourself. You can run it on various devices, and it's a storage system. It could act like a file system if you wanted to. It could, you can search it, you can index it, you can share it with friends. It's kind of a fun project.
So what was the primary motivation for creating Camlistore?
I had a lot of different machines and a lot of different phones, and it was kind of confusing where my data was and which direction I was supposed to back up. And I also didn't really want to organize my photos. I just wanted to take photos and have copies of them. So I also wanted to publish my website kind of out of the same data repository that I had the rest of my content in. So I wanted kind of one CMS for my whole life that was a mix of private and public as I chose. And I was sick of just building new CMS systems all the time. So I wanted kind of like one data model and one CMS that I could like build all my future products off of.
Gotcha. And so what are some of the practical things you're using Camlistore for today?
Right now, it's largely my backups and also like all my photo management and sharing photos with friends. But I'm starting to use it for more things like serving my website and stuff like that.
So just content management in general. Great. So so let's dive into kind of the demo and the details of what's involved here. The basic building block in Camlistore is a blob. So what is a blob? Can you show us what that is?
Yeah. First, let's start a server. And we can walk through some of the command line tools first of all. So everything in Camlistore at the base is a blob. All the higher level data structures are built on blobs. So let's say we have a blob hello world, and we want to store it in Camlistore. The very most basic thing we could do is just put a raw blob in. So we now have hello world and a blob. The blob is identified by a blob ref, this guy here. And if we call cam get, we can get it back, and we can get the hello world back. So
when you did cam put, what did that do? Like, where did the data actually go?
You can actually choose all the interfaces to the server are HTTP, but on the back end, you can choose to store it on local disk. You can store it on S3. You can store it on Google. You can basically whatever you want to write a little adapter for, and we have 4 or 5 of them. You can store it on any storage system.
Great. So that's kind of a dumb blob, putting and getting a dumb blob. You also said there are structured blobs that provide more information. What are those?
Yeah, so a lot of people don't want to just store just a blob because people aren't going to remember something like that.
Right.
So you can store, say, a file. Maybe we have a file, hello world. We put that in hello.txt, and we want to put that file. Cam put file hello.txt, and now we get this guy. But if we can get that, instead of just being the blob, now it's a metadata blob. So there is no metadata in Camlistore. Everything is either a blob or it's a blob about other blobs. And we happen to use JSON because we believe in digital archaeology and being able to come back to this in a number of years when people really don't know what the system is and kind of recover all the data just from looking at it.
So it's kind of self-describing data.
Yeah, all the metadata is self-describing.
Gotcha.
So here we say that this thing is a file. It has some Unix mode bits, and it has a mod time, the user and group that I was currently running as, or when I created the file. And then it also describes the chunks of the file, the parts of the file. So if we can get this guy, that is my mistyping.
So that's the dumb
hello
bytes
world.
from before.
That's the dumb bytes.
Gotcha. Now, that's just a file. What about a directory, let's say?
Yeah, you could, let's say I have a directory called things here with 2 files and just 1 and 2. I could then cam put the whole things directory. And I have some verbose debugging on right now, but the thing I got there at the end was this identifier, which, like the file one, says that it is a file, it's a Camly type directory, is the schema type that is being represented. File name is things, mod time. And then it has some entries, which is represented by this hash. And that's a static set. And each one of those then is a file. And you get all the way down, and eventually you get back down to a
the actual
content
data.
of
So,
one.
so you can traverse each metadata blob
Yep.
to get to the next and kind of get a snapshot, a picture of everything.
Yep. And every time I put it, I get the same content because the directory hasn't changed. So I always get back to this guy.
So you never have more than one copy of the same information.
Yeah, everything is naturally deduped because everything's content addressable.
Cool. So it seems like so Camlistore is this specification. It's an implementation. It's a schema for how these metadata blobs should work together. But mostly what I've seen is that it's immutable data. It's content addressable. So if I changed a file in the directory, you'd have to go back through all the metadata and modify each level all the way up to the root if you actually wanted to mutate a file system. How do you do mutations in this situation? How do you make it so that Camlistore's read and write?
Yeah, like you said, everything is kind of immutable so far. I can have some identifier like this. It's a directory, and basically all I can do with it is look at it. I can even say mount it if I want, and I could say.
Oh yeah, right. Yeah. So if you had a backup, then you could mount.
Maybe this was my home directory, and it was terabytes and terabytes or something, and I can mount this at some point, and well, now you see all the fuse debug operations, but then I can open this, and now I have what looks like a volume on my Mac, and I can open these files up.
Right.
And, there's the file 1, and close that guy. There's the file 2.
Right.
Can unmount that, but
gotcha. So you mounted it, and that's all an immutable file.
yeah,
system.
that is just basically a snapshot of
Okay.
of some backup.
So now, if you're going to actually mutate the files, what's involved? What's involved
Yeah.
there?
So the way we represent mutable data is with what we call permanodes. A permanode, the simplest way to create one is just camput permanode, and every time you run this, you get back some new identifier. And if you actually look at one of these guys, it is Camli type permanode, and all that it has is a random number in it. And every time you run it, it just makes a new random number. But the two interesting things here is there's a signer, which is me, and everyone has their own identity. And if you look at it, it's just a PGP key.
Gotcha.
Open PGP. And it also has the signature. So anyone can verify that I actually signed this random number. But the whole thing is valid JSON, just like everything else, all the other metadata in the system. And now this is basically my handle that I use to represent the object.
The mutable object.
The mutable object. And otherwise, if you were mutating a file in a directory, all the things would percolate up to the top, and the root would change. And if we actually want to have a mutable object that we give out and hold a reference to, have a URL to, if you want the permalink equivalent, that's why we call these permanodes.
So what can I do with a permanode now that I have this ID?
Yeah. So one thing you can do is you can change an attribute on it. So I can, on that permanode attribute, I can set foo equals bar. And now if I look at that guy, that itself is a blob, and this is a blob of type claim. The claim type is set attribute, and I'm setting the attribute on this permanode, and the value is bar. And there's also a date that I set it, and again, my signer. So anyone else in the world, regardless of how I share or replicate this blob around, can verify that I said this at this time.
So now this is getting it's still pretty dorky. We're here in terminal land. Is there a way to see these blobs besides that?
Yes, you don't have to use the command line.
Okay, that's good.
So bring up our demo UI.
Cool.
And so now, well, we don't have a title on it, but here is the thing we just created. There's the permanode, and you can see down at the bottom here that the indexer that's running along with the server, and you could run the indexer in the search wherever you want at a different place. It says that foo is bar here. We could also go back and set something else. We can say the title, which is an attribute that's known to the system, is let's say this is demo node, and we created another one. If we go back to the home here, we see that it now says demo node.
So now this is just a little blue dot, though. It doesn't really have any type information. It's just this handle to a permanent reference.
I mean, this is kind of boring. We're just setting things, and we can go in here and say we could add some tags. Maybe this is funny and demo, and this is created. Now we have some single valued attributes like foo only has bar, and tag has multiple values.
So we're attaching a bunch of information to this permanode to describe it.
But so far, this isn't very interesting. Let's put a file. For my desktop, there's fix mind. So we're uploading this from my desktop to the server. And if I look at this, this is a file node,
Gotcha.
a file schema. And I can go back and set an attribute on that guy and say,
On the perma node.
on the perma node, and I can say Camly content, which is a magical attribute that says what this perma node is. So you can think of a perma node as basically like a stem cell that can become any sort of object later. And the UI, if you go back to the home, only shows you perma nodes. That's kind of like the unit you interact with.
Right.
So let's set Camly content to that file I just uploaded.
So you uploaded the file. That gave you a content ID, which is kind of the meta information about the file itself. And then this Camly content attaches the file that you uploaded to that permanent link, essentially.
So now if I reload that, I actually see that it's now associated with this file,
Right.
this demo node. And you can see the attributes here. I still have foo, funny, demo, and demo node. And I can go download the image and stuff.
So now every one of these modifications has added some information to your Camly server, a set of claims. Is there any way to look at that list of claims?
Yeah, if I go to view blob, this is kind of a debug page. You can see that here's the perma node, which is, again is just a random number that we use to attach all these other claims.
So that was the first thing you did.
Yeah. And then the indexer is sitting here running, and here's what the indexer knows about this thing. It now knows that these are the current resolved attributes at the current point in time. You could actually ask it questions as of any point in time. So you can say, what did your world look like yesterday or an hour ago?
So the indexer keeps the current state of the whole world.
Yeah. And it also keeps a list of all the mutation claims that have made on that perma node. So the first one we did from the command line was set attribute foo to bar. We set the title to demo node. We added funny. We added demo. We set Camly content. I can actually go back and
like how do you do a delete? Like if you delete a tag?
Yeah, if I delete, let's say, this isn't very funny. This is actually kind of boring. I can delete that. And now it looks like, I only have one tag. But if I go look at the blob, funny is still there as an attribute that I added.
And that's the former claim.
The former one. But then I have a delete attribute. And I said, OK, this is no longer funny. And I deleted that. But if you ask the indexer what the state of the world is, it only has, well, that was in my cache. But if I reload that,
oh, maybe not. Oh, there it is. OK, it was cache.
Yeah, I had to.
Right. So you always append to Camlistore, and then the indexer figures out kind of what's current.
There are deletes, but they're kind of logical deletes. The underlying layer you basically never delete unless you run like a full garbage collection and you actually care about deleting content. The philosophy is that disk space is free, so we don't really care.
Now, so what are some other ways to get data into Camlistore, like other ways to upload information?
Most people are not going to be using command line tools, so we also have, say, drag and drop a file onto the web browser, and you can kind of see on the server it's receiving all the blobs, cutting up into lots of little chunks, and here it's now the server or the web UI created a perma node, and the file name by default it doesn't have a title, but it inferred the title from the description. If I click through here, you can see that this is the file descriptor of the file, and here's all the chunks, and it actually cut it up into lots of little pieces into kind of a tree of chunks.
Now, why does it do that?
So all the blobs, it tries to keep relatively small so it can verify them, and also it cuts them on rolling checksum boundaries. So if the file shifts around a little bit, maybe you modify the EXIF metadata or the ID3 metadata, the file doesn't get re-uploaded because the checksums only look at little small 32-byte rolling windows to figure out where to cut it up.
So essentially, that's another part of making Camlistore allow for mutations. So even though you upload everything content addressable, if you had a 1 gig file and you only modified 5 bytes, you wouldn't want to upload the whole 1 gig again.
So you can keep VM images in this and save snapshots between them, and it stores the minimum delta between those files.
So it'll efficiently cut it up into chunks and only upload what's changed. It's cool. So now, synchronizing data from all over the place is kind of one of the goals here. So here you're uploading from your computer. You also wanted to be able to upload from a phone or have many computers synchronized. So you have a phone here. And so you're going to show another kind of example.
Yeah, there's an Android client, of course. It's not the most beautiful UI in the world, but see if I take a picture of you. All right, got a nice blurry photo of you there. I could then go in, share with the Camly uploader, which I guess is this one here, the default one. And then you can actually see all the debug data of how many chunks. You can see my server here going, and it got them all and got this file.
Cool.
And if I go back into my web UI and reload, we should probably make that live reload with WebSockets or something. But now I see this picture of you.
Cool. That was pretty quick.
I can go in there and I can say, Brett, save that attribute, and I can, maybe tag it. I'll call you funny.
Sure.
So then later, if I want to go in and I have all this stuff, it's sorted by, recent view time or modification time. I can either go back in the search, and search for things tagged, Brett.
Oh, there I am.
And find you back.
And can I look at the recent information like on the desktop otherwise too? I noticed you had mounted my backup directory, but can I synchronizing between the phone and the desktop and the web view all together?
Yeah, I could run cam mount.
So cam mount is the kind of file system tool under the covers, right?
Yep. And so I've just mounted my whole Camlistore repo at /camly. I opened that up. And there's things like there's this synthetic recent directory. And if I go into recent, I can see here's some things I uploaded. So here's the picture of you.
And so while I touch all these things, it's actually going out to the server, pulling all the blobs down, and bringing those into your user interface here, creating a preview. So it looks like that first one just loaded. Right. So this was uploaded from your phone to the Camlistore server and then mounted
on the Mac, pulled from the server that we currently are running on a VM for the demo.
And caching all the way through.
Yeah. So I never had to transfer it from my phone to my laptop. I just it looked logically like it was there.
Great.
In a little recent directory.
So now we have all this data, and now I want to share it. Let's say you've taken a photo of me, and I want to give it to somebody else to show. What do we do today, and what happened, right? So how do you share in Camlistore?
Let me kill that guy. So one thing I could do is, let's say on my desktop I have all these pics. I could upload all the pics, and I get the handle here for the whole directory, and I can give that to somebody. So I can say
the snapshot. This is a snapshot.
Yeah, this is just a snapshot of all my stuff. By default, all your stuff is private all the time. It's kind of like your email is all private, and if you want to make something public, you share it to them. So what I can do is take this directory, and I can put a share claim. So I can say someone has access to this blob, and I can say transitive. They also have access to all the things that are reachable from that blog. So give them access to the whole directory. Yeah. So I can put that, and I get another blob back. And if I actually go look at this guy, this is another metadata claim.
Right.
We say anything that's signed is a claim. So it's Camly type claim. The claim type is share. I'm saying that the target is this. So this is the thing I'm giving you access to.
Which is the directory.
That was my directory of pics.
Right.
And the authentication type, this is how you have to prove yourself to my server to get access to these things, is havref. This is the least strict authentication type. This is basically the secret link.
Anyone with a link, yeah.
You could imagine, there's also username and password, or authenticate with OpenID, or Twitter, or Facebook, or whatever. So if I want to give this to somebody at this point, I give them this.
Right.
And
and that's like a handle also, right?
Yeah.
Yeah.
And so then they can say, cam get shared, and then, whatever the root of my server is. And of course, they wouldn't actually do this because this is dorky, but I'm trying to show how things actually work. And then I could say, oh, let's put it at, desktop foo. And this is then created a foo directory over here, and it's currently populating it with pics, and there's all the pictures.
So this command goes to the server, it looks at the claim, it sees what you have access to, it finds the directory, it traverses that, gets all the blobs under that, all the data blobs below that, and then reconstructs it on the other side.
Yep, and it follows all the chunks, and every time it makes a request to the server for a chunk, it proves to the server why it has access to that, and it tells it the path that it has access to. So,
great. And so that's for private sharing. What about just publishing these pics? What if you took the pictures and then wanted to put them online for anyone to see? How would that work?
Yeah, so
because we were talking about how this is like a content management system to rule them all, so private sharing is one part of that, but publishing is another part of that.
Yeah, so you could actually, this could publish your photo gallery as well. The way you do that is, first of all, you have to configure a node to be the root of your publishing, the root of your website or whatever. So let's call this, my website.
And we said node, you mean a permanode, right?
Yeah, I need a permanode to represent the root of my website.
Okay.
So I have one of these now. I just created it in the web UI. And so I have to configure my server to actually publish. So I'll kill my server and go back to the config file. And in the publish section, I could put a little section here that says, I want you to serve at /pics. I want you to serve whatever the content of this permanode is, and serve it with the template gallery, like a photo gallery. And this is my CSS to use. So if I restart my server, and go back here, I can now do things like, here's this picture of you, and I want to publish it. I can say the access for this is public, and I want to serve it at /pics/Brett in demo or something like that, and set URL. What this actually does is make a new claim, and it's a claim that within, go look at it if we wanted to. The mutation claim is that the path Brett in demo from its root is now the value of this thing, which is your file. So it's like claims pointing to claims.
So it's like turtles all the way down.
It's turtles all the way. It's blobs and metadata all the way down.
Yeah.
But the cool thing is now I can go, it gives me this public URL that I can share with the world at, my Camlistore server /pics/Brett in demo. And there you are, served to the world.
Great.
And friends could download a whole zip of a whole photo gallery. Or here, we can go serve a couple. Let's make a new node that just serves. I was just in France. We can make a node that's called France, and then we can actually let's take this picture and these pictures. We'll create a set with them. Now I'll just call this one France, whatever. Make this public. Make a URL. Mount it /pics, saying France 2013, and now we have a photo gallery of that stuff.
Right. So it's a single way of describing all of these different parts: personal backup, saving all your files, sharing your files, publishing your files. So that's why it's really a content management system for all of your data at the same time.
Yep. And the cool thing is, in this publish, you actually look at the source. You see that all the metadata about the blobs and the relationships is all in the JavaScript, so you can play with it and style it at will.
That's cool.
Move stuff around.
So, thanks for showing everything to us today.
Yeah.
I forgot to mention, this is something that I've worked on too. A lot of people on the internet have contributed to. It's an open source project. It's written primarily in Go, and it sounds like right now it's mostly for developers to be doing this. To download the source code, to build it, to use it for their own backups and things like that. But what's next for Camlistore in the project in general?
I think more publishing blogs out of it, photo galleries, maybe incoming email, indexing your email as well. Better Android client, better web UI. Right now, everything kind of works, but everything's a little ugly. The Android client is ugly. The web UI is ugly.
It's more like trying to figure out how to fit all the parts together, right?
A lot of time was spent figuring out the data model and the replication and the sync and.
Right, and so you guys just had, Camlistore had its first release ever a couple of weeks ago after 3 years, right?
Yeah.
So it's kind of been in development, getting the data model just right and all the code. And now we had this first release, and so it's kind of more ready for contributions from everybody. If I'm a developer out there and I want to contribute to Camlistore, how can I do that?
Download it, report bugs, play with it. I mean, we've been putting all our data in it for about a year now, but of course I trust myself, but you probably shouldn't trust me. So keep other backups, I guess. But it's definitely fun. I have a friend who's now using it. And there's this camtool sync command that you can sync between sources. Here, if you just sync to standard out, you see a list of all your blobs. But it can do like a 3-legged sync where I can sync from my server to a server far away. He has a country house, and the internet connection there is terrible. So he can talk to that server with camtool sync and decide which blobs are missing, but then sync instead to a portable hard drive that he drives out with him. And then he could sync the other way.
Right.
And so really, once you have this data model that's all immutable, it's very easy to do lots of fun things.
Right. That makes a lot of sense.
Never lose any data and move it around and sync real easily without overwriting old versions.
Right.
So
cool. Well, great. All right. Well, I think that's all the time we have for today. And thanks for coming in, and thanks for watching.
Right. Thanks.